Hi, it's Bruce here, and welcome to my Colorado Rocky Mountain Lab. And what we have today is a project I've been working on the last month or so. And what it is a 5-decade capacitor. It uses polystyrene capacitors that are better than 0.5% in tolerance. And we cover 5 decades, like I mentioned. We go from 0.1 nanofarad up to 1 microfarad. And yeah, it's 1 microfarad at less than half a percent tolerance. It was the most expensive part in the entire unit. So what do you do with this? Well, one thing you would do would be to check, say, the linearity of maybe your capacitance meters over 5 decades. And how many decades are these things good for, and just how accurate are they? I've already run a test on this thing, but I can tell you that the accuracy is such that we are better than 0.5%. In fact, most of the time we're around 0.25% in error. So, and that's over 5 decades using this DIR EE unit. So here we are at 0.1 nanofarad. We started 0. At 0, we see we had a reading of 5.7 picofarad in this case. At 0.1 nanofarad, we got 105.7. So you take that away, you get that's 100 picofarad, which would be perfect. Zero tolerance, in fact. This would be 1 nanofarad, and we have 1006.3. Well, you take away 5.7. 0.7 picofarad away from being a perfect tolerance. If we go to 0.01 microfarad, or it would be 10 nanofarads, we've got 10.054, take away 5.7, and you basically right there at perfect. Here we are at 100 nanofarads, and we got 100.21. Take away the 5.4 picofarad. And right offhand, I can't tell you what that is, but I can look it up. And then 1 microfarad, we are running 1002.0 nanofarads. 2 nanofarads out of 1,000. They're polystyrene for a reason. Polystyrene capacitors have extremely low leakage. So they're perfect for use in an integrator, where you need to store a charge, for sample hold devices, and so on. So I've covered 5 decades. That should give us a lot of room to choose any value we need over a wide range. It's a simple enough schematic. As you can see, we have a 6-position switch, and then we have 5 capacitors. The lowest one runs 0.1 nanofarad, or 0.0001 microfarad. Then we go to 1 nanofarad, then we go to 10 nanofarads, 100 nanofarads, and 1,000 nanofarads, which is a microfarad. And then they're wired to the outlet. And we used polystyrene 0.5% 250 volt capacitors. So we'll open it up and just give you a look at the inside. It's not too extravagant, and like the exterior, I have a vinyl sheet with printed labels on it on the outside, and it came out okay. It's not perfect, but it came out okay. I ordered some new vinyl sheet and with the adhesive on the back. We're going to see maybe if I can make it better, but for right now I'm happy enough with this. I'm going to go ahead and open it up. Okay, so now we've got to look at the interior. And what we see is we have a bus bar for the common. And all of the capacitors attached to the bus bar and then run to the switch for the various decades. We have the largest capacitor by far is this polystyrene 0.5% 1 microfarad. And that one unit right there is responsible for about doubling the cost of the whole project. But it was an important decade for me. I wanted to be able to reach at least a microfarad. And here we see we have 2.02 microfarads. We got them in series, so it's 0.01. Got a 1 nanofarad and 100 picofarad. And I believe that's 0.1 microfarad over here. And then we have the output terminals. So, not real exotic. 5-position switch, well actually 6-position. One of the positions is 0, so we can read the residual. And we have 5.7. And basically that's it. Nice compact little unit, and it works well. Thank you.